Hello, this is Nick again, and just continuing to create these videos about physical science. In the previous video, I discussed some basic. The slope could be positive or negative, depending on the direction in which it's pointing. I showed where there was also the equation of the line, the coordinates, the types of graph. We have distance time graph, velocity time graph, and also acceleration time graph. But basically that was to give some general ideas of what to expect on the graph, because the information about speed and motion in physical science needs a very good understanding of the characteristics of a graph and the processes of the graph. So that was very important. So in this video we're going to deal with a constant. Constant is a very important part of graphing. So this video specifically talks about constants. What is a constant? A constant is really the rate of change of one variable with respect to another variable. For example, the distance traveled over a period of time, that's a rate, and that rate becomes the constant. Or the velocity measured over a period of time, the acceleration measured over a period of time also. So all of those can have a constant. Other constants that can be created could be the population increase over time, the change of the acceleration of molecules, as the amount of heat increases. There could be a rate there. There will be a rate there, and that rate can be calculated, and it could be a constant. How about the change of the effects of global warming as carbon dioxide emissions change? That could create also a constant. Now, how can we see a constant, or how can we see constant in a graph? Let me just show. By looking at the slope or the gradient of a line. For example, here we have a distance time graph, and in this distance time graph we have this constant which is the slope. Okay, so this is how we see the constant on a graph. In a velocity time graph, this is the constant. It is the slope or the gradient. And then in an acceleration time graph, again, this would be the slope or the constant. The constant is the factor linking two variables. In this case you have y and x, so that y is equal to the constant multiplied by x. And incidentally, it could also have been x is equal to some constant multiplied by y. So the value of y could only be equal to the value of x if the value of x is multiplied by the constant. And of course it's the same thing. The value of x could only be equal to the value of y if the value of y is multiplied by a constant. Do constants change? No. As long as the slope of the line remains the same, the constant does not change. Do constants change? Yes, if the slope of the line or the curve changes. If you have a steep line or steep slope, the constant increases. If you have a low curve, low slope or low gradient, then the constant is low. The value is going to be less. Do constants change? Yes, if the variables change. In other words, if we're dealing with x and y and the slopes are the same, the slopes are the same angle. And by the way, when we talk about gradient, we're also talking about the angle. So if the slope has a steep angle, then the constant is going to be high. If the slope has a steep angle, an angle that looks like this, that would be high. But if it has an angle that looks like this, then the constant is going to be low. Alright, so if you have x and y and the slope, the angle of the slope, is the same, then the constant is going to remain the same. However, if you change the variables, let's say instead of x and y, you change the value, you change the variables, and the variables are now s and p. That is like changing it from velocity versus time to population over time, or population or over some other factor. So does the constant change? Yes and no. The value of a constant is a fixed value only for the conditions stated. Okay, so the value is fixed, but it's only for the conditions that state. In other words, once the conditions are set, are stable, or unmoved, then the constant does not change. How is a constant calculated? K, in this case the constant, and by the way, we're talking about K being the constant here, but in some cases the constant could be an M, so don't be surprised if you see M as the constant in some cases. So A is calculated in the following manner: y is equal to K times X. Now, using some algebra, you can see that K is going to be equal to y divided by X. And here we have an example here. If y is equal to 15, that is the dependent variable, that's the vertical axis, and X is equal to 3, the horizontal axis, the independent variable, then the constant is going to be 15 divided by 3, which is equal to 5. So in this case, the constant would be 5. K is going to be equal to 5. Okay, so that's all for constants for now. I hope you were able to understand certain aspects of the very important concept of a constant as it relates to the velocity, acceleration, or anything that has to do with two variables. The next video will be examples of direct and indirect proportionality. This is Nick. Thank you.